Thanks to everyone for joining us today for our webinar on LoRaWAN digitalization with Ignition, hosted by Moxa with guest speakers from Inductive Automation, MultiTech, and SiteSync. My name is Oliver Wang. I am the product marketing manager for the Edge Compute line here at Moxa. We're going to be covering these three main topics today. We're going to go through some background to LoRaWAN and its relevance to digital transformation, how Ignition is uniquely suited for digitalization at scale, and we'll present the topology that SiteSync has developed to achieve this in practice. So before we get started with the presentation, a few quick housekeeping items. We will be posting and sharing the recording of this webinar, and we do want your feedback and questions both during the webinar and afterwards. Here are some of the questions that folks have already submitted when registering, so thank you for that. You can use the Q&A function in your Zoom interface to submit questions at any time during the webinar, and we'll speak to them at the end. We'll have some time for the live Q&A at the end. So, I'm very honored to present our guest speakers. Joining us today is Daniel Quant at MultiTech with 25 years of experience in wireless and telecom. He made some time out of his busy schedule in between flights for this webinar. Thank you, Daniel. He also serves as the chair of the LoRa Alliance Marketing Committee. We are also very lucky to have Travis Cox, the Chief Technology Evangelist at Inductive Automation. Very well known, very active in his support for Ignition users and the Ignition community. And we have Michael Brower from SiteSync, new Ignition Alliance partner with a talented team of software developers. SiteSync is a software solution from BBP, so you will see both names in their marketing collateral. So thank you, Daniel, Travis, and Michael for joining us today. Daniel, can you get us started with some background on LoRaWAN?
Yeah, sure, Oliver. So I like to start these things with a polling question. So let us know if you're brand new to LoRaWAN, or maybe you're familiar with it, but you've not used it. Maybe you've done POCs and trials, in which case go for the third one down here. And let us know if you have actual solutions out there in production scalability right now. So don't hold back. It's all anonymous. And so let's see what our audience has to say here today.
Thank you, Daniel. And I apologize. My Zoom interface sort of flips on and off, so it took me a while to launch the poll, but it is launching. You guys should see those questions, and we are getting some answers rolling in. We'll see those answers in just a bit. Give you guys a few more seconds, and let's go ahead and see the results.
Right, brand new to me is 40%. Right, okay, but great to see 15% of people have LoRaWAN in production. So, as I had imagined, a bit of a mixed audience here. So for those that are new, let's jump into this. So LoRa is part of a technology grouping called Low Power Wireless Access Networks. And there are a number of different technologies that meet the criteria of low power wireless access. And they all have a very similar hallmark to them. They're all technologies that are designed to communicate a low amount of bit rate. You know, let's call it kilobytes per day, but for most objects, it's not even kilobytes, right? But this is not megabytes, it's not gigabytes. And typically, this is going to operate over very long distances. So don't be thinking meshing, thinking, you know, direct point-to-point communication over long distances. Exceptional in-range building penetration and range, typically running on batteries for years. And there's a number of these technologies on the market. If you move to the next slide, and various different technologies addressing various different use cases. So here in 2023, we're almost 1.5 billion lifetime deployments of low power wireless access, principally going into things like utility metering, asset location tracking, compliance, automation, condition-based monitoring. And it's interesting to note that LoRa is now the standout technology in this genre. It's selling and shipping at about a 2-to-1 ratio with about a 30% CAGR growth. So whereas today it represents about 20% of those 1.5 billion units shipped, and once we get into 2025, it starts to look more like 40+%. So if we flip to the next slide. So here's a pictorial representation of where LoRa sits. On the one side there, we've got bandwidth, so super high bandwidth as you go up, a few bytes in a day at the bottom of that scale. And then we're showing range, so link budget, how far can you get that signal? And obviously Wi-Fi and Bluetooth is all about broadband connectivity. And we know it well, it works in our office. Maybe we can cover our house, maybe we need to mesh it, but we can get broadband communication. Cellular also gets broadband communication and it gets range as well, but it does that by communicating at a very high amplitude. It shouts loud, and of course that requires power, and that's why we have to charge our devices every day. They don't run on batteries forever because of that high power. LoRa, on the other hand, gets long range, but it gets it at a very low power level. So you're able to measure range in miles, but you're measuring battery life in years. And it does that because it uses a low power signal, which has great noise immunity and coexistence. And even though it has great range, you can use it in buildings because it has great in-building penetration. All right, so if you move to the next slide. So like all technologies, LoRa has an alliance called the LoRa Alliance, founded by 14 or so companies, including MultiTech, Semtech, and a number of others back in 2015. And now we're an organization, an alliance of 400 or so members. And this really spans the full gamut from semiconductor companies, modules, sensors, gateways, and software platforms, integrators, and service companies. So it's a very broad ecosystem, and that ecosystem is innovating at breakneck speeds. This isn't just, a race to the bottom line in cost, although of course having lots of members makes it a very competitive technology, but it's also super innovative. And the LoRa Alliance has pulled together a number of different specs that complement this technology, from the application layer, back-end interfaces, and low-level Mac specs, and put a whole interoperability system around that. So it's a great example of industry collaboration. Next slide. So one of the reasons why LoRaWAN is the standout technology in this segment is because not only can it work in a public network, like say narrowband IoT or Sigfox, but it can also work in a private network. So there is 160 something public networks out there across over 150 different countries in the world. We may not see the adverts on TV, but there are plenty of these public networks. But there are literally thousands, if not tens of thousands, of private networks where the cost can be capitalized, the performance can be very targeted to a very specific coverage area, application, use case, and the network configuration that needs to map that. It's also interesting to note that devices can come in and out of private networks and into public networks, and that's hybrid. And this elasticity in OpEx, CapEx, broad coverage, private focus coverage has been a key reason for the success of LoRaWAN. We move to the next slide. So how to build a network then? So you buy devices. They could be hazardous rated, ATEX, class 1, div 1 devices. They could be low cost, $30 sensors. Those sensors, hundreds, thousands of them, connect to a gateway. And then the gateway demodulates that data, and then over an IP interface brings that data into a back-end platform. Could be a SCADA system, process control network, or it could be a cloud platform like AWS or Azure. So it's devices, gateway, and a software platform for that data to be ingested into. One of the things that we've been doing with Ignition and with Sync Automation is how to simplify how sensor data is being brought up into these SCADA systems, either directly into those systems or into a data lake that is part of that silo. And this greatly reduces the time to market and complexity. If we look at some of these layers here, and I know many of you are very familiar with this, even the sensors, they're typically wired into an enclosure that requires CAD drawings, it requires planning, it requires experience and discipline. And then all of that is connected into PLCs and DCS units with ladder logic or Python or what have you to make sense of it, to then have to go into maybe Modbus and field area networking protocols. And when you're controlling assets, especially mission critical assets, this all makes a lot of sense. But if you're just harvesting data up to be able to better understand the environment, be able to make more data-driven decisions about how you control assets, then it's overkill. And it's one of the reasons why there's so many stranded assets out there, because this business case just didn't loan it to connecting anything but the most significant and important assets. LoRaWAN is able to completely transform this, create a paradigm shift where low-cost sensors, cable tied, magnetically attached to motors, pumps, compressors, and that data is sent immediately into a gateway and injected directly into those SCADA systems. We move to the next slide, Oliver. So ton of different use cases that LoRa is being deployed in today: equipment monitoring, pressure, valve level, vibration, worker safety use cases, chemical tank monitoring. It's connecting so many stranded assets in so many different market segments. And of course, environmental social governance. And if you can't measure it, how are you going to manage it, right? So this is a great way to be able to really start measuring sustainability targets. So if we move to, I think, what is the last slide here, some of the things that have held back the market, particularly in these industrial segments, has been how to onboard gateways and end devices. This is a telco infrastructure, and it has to be in order to create that massive machine connectivity, that just massive amount of devices connected. And that requires complex IDs. Where is the core network piece going to sit? That has big impacts on business model and how to support this network. There are a lot of data, a lot of sensors out there. There's getting on for 200 temp sensors that are natively supporting LoRa. How do you get the data out of those sensors? Because each vendor has carved that up a little bit differently in their sensor. And then how to manage the life cycle of these networks and troubleshoot devices and gateways in the field. So I'm going to pass that on to some of our other speakers here to kind of deep dive some of these pain points. So back to you, Oliver.
Thank you so much, Daniel. That's a fantastic introduction to LoRaWAN. And I see some questions already coming into the Q&A. So thank you, attendees, for submitting those questions. I haven't had a chance to look at them. We'll get to them at the Q&A section. I didn't want to interrupt the flow of the presentation, but thank you very much. So Travis, let's talk about Ignition and its role in digitalization. Let me go ahead and hand it to you. And it looks like we're starting with a poll. So I'll go ahead and get that started.
Yeah, absolutely. So we want to kind of get a sense of people's familiarity with Ignition here. If you're new to it, if you've had some experience with Ignition, or if you're deploying a lot of that out there, kind of give us that sense. But what we want to really share today is sort of some of the challenges that we have with current bringing data currently with LoRa into Ignition, and but also kind of represent the opportunities that exist around that if we do it really well. So all right, now with the poll completed there, kind of where I typically see that a lot of folks here are new to Ignition. So I'll give a little bit of a familiarity with what Ignition is, and of course we'll go into the topic of LoRa here today. Perfect. So let's go to this. So for those of you who are new to Ignition, Ignition is an industrial application platform. So it's a development environment, a platform to develop any kind of application. Typically falls in the category of HMI SCADA or MES. But of course, we're looking at moving data around, leveraging cloud, opportunities, if you will, in the IoT space. Ignition is a platform that is completely unlimited. The licenses, we don't charge by tags or screens or clients. It's fully unlimited for all of that. It's completely cross-platform. It's built in IT standard technologies, which is really important, especially when democratizing data or making data available. So data we're bringing in from these devices, we want to make that available to any other technology, to other systems, and kind of bridge that OT-IT gap, if you will, by leveraging standards, open standards, and IT tools out there. It's very much a scalable server client architecture, all web-based and web managed, very simple to deploy out applications to people on no matter where they happen to be, on their phones or tablets or PCs or smart TVs. You can get that information out to people. So it's really around being a data hub, bringing data from different systems, being able to contextualize that data, get that data available, and build robust applications that people could do that. And they could do that very easily in our rapid development and deployment environment. So that's a little bit about what Ignition is. Let's kind of talk now about some of the challenges that we have seen with bringing in these LoRaWAN devices in Ignition. Now we talk about MultiTech here as a MultiTech device that you join your LoRa sensor to that, and ultimately from there we do get that data into Ignition. Data does come easily into Ignition via MQTT. Well, the problem is, of course, that the data is a binary format. Every sensor has different formats for what that data looks like. So that means that within Ignition, we have to do the parsing and basically contextualize that data, build data models out of that. Of course, something that we can do, but often it requires scripting or requires you to especially people that are more that are beginners. It's harder for them to get the data in the format that they really want it to. So the big challenge is that the data is not in a usable form that is just readily available, and that there's that lack of data context where we understand what each of the data points are, what the valid ranges of those data points are, what the engineering units are, and so on, right? So that has been a challenge for a lot of folks out there, and this goes for a lot of devices or sensors that they're talking to, where we may be able to easily connect to it through some mechanism, OPC, MQTT, or something, but then that there has to be extra steps that we take afterwards. So these challenges have existed for a while, and today we're going to show you how we can overcome those challenges. The other, of course, is that if you have a lot of LoRa devices out there, you've got to, it can be a challenge to join those devices to the LoRa network server, and basically to get that so that the data start flowing into Ignition where we can use it. So the more devices we have, especially if we start deploying them everywhere, there's that challenge of not only getting connected, but then getting that data into Ignition in the form that we want it. And if we introduce new sensors that have new formats, of course, we have to go in and build that in Ignition. So hopefully I'm kind of painting that picture that's there. It is certainly possible to bring that data in, but the idea is that what we really want to do is have that data with its context already being brought into Ignition so that we can unleash the power of that data. And ultimately, we can do a lot more with it. So if we go to the next slide here, that's really the focus of what of this webinar, kind of where people are trying to go is they want to take that data and leverage that data a lot further. And there are limitless possibilities with being able to leverage, Ignition and LoRaWAN to do a lot with it. So what really starts happening is that you get a single source of truth to your data. If we contextualize it at the edge, we have all that structure there. We can then bring that data up. We can securely deliver that data to infrastructure using technologies like MQTT and Sparkplug. That data can be brought to IT very easily, can be brought to the cloud very easily, along with that structure, so that we can leverage things like digital twins or machine learning or artificial intelligence, and where we can really have data-driven decisions that are happening there. Now, that's talking about moving data around. That's really important to be able to get data where it needs to be, kind of democratizing data. But it's also really, really important to be able to provide this data to people very easily, bring it onto screens and build dashboards that people can utilize anywhere they happen to be. It doesn't matter who they are, doesn't matter where they happen to be. You want to be able to utilize that data. And especially today, it's true with mobile devices. We want to get data on our phones and our tablets. We want that to be mobile with us as we move around, to be able to easily get access. So that is, there. Once we bring that data into Ignition, there is a whole slew of possibilities with that data. And the more that we can do to get that data in a usable form faster, the more possibilities that open up with that information. So that's kind of what I want to do is here, just kind of set the stage for what we've seen so far with that. But lucky for everybody here is that we've got a really great solution between Ignition and SiteSync, where we make the access to this data a lot faster, a lot easier. And so with that, I'm going to turn it over to Michael to show you guys the work that they've been doing.
Thank you so much, Travis. That paints a really good picture between Daniel at the LoRa side and then Ignition on the platform side of what you do with the data. Michael, you're up. I'll go ahead and share my screen, and then when you're ready to share on your side, you just let me know.
Yeah, it should be ready to share now. Very good. Well, Travis, Dan, Oliver, thanks for the nice introduction and segue into our section. What SiteSync aims to do is we aim to be the easy button for getting IoT devices like LoRaWAN and other wireless technologies into platforms like Ignition. We've seen a lot of challenges as we've done that over the years. We got into this journey by working with Arlen Nipper, and he was working with Chevron on deploying LoRaWAN devices in the Bakersfield oil field. They deployed a LoRaWAN network, had looked at chemical tote monitoring, we're getting levels off of that. They had a sushi vibration sensor and said, hey, I have this LoRaWAN private network out here. How can I leverage more sensors on it? I want to add this sushi sensor in. And when he came to us and said, how do I get data out of this? We realized, every LoRaWAN sensor has a unique encoded data type that requires you to support a library of decoded sensors. And we were like, if someone doesn't step in and help make this easy, it's going to be hard for this technology to be developed, to be deployed by end users in the heavy industrial market, in the general manufacturing environment. And we really saw a need. And one of the things we wanted to do was work with open platforms. And that's kind of why you see us with this architecture here, choosing partners like MultiTech, Moxa, Ignition, and being a part of the Alliance program ourselves. Is we view, in order for this technology to be enabled and deployed at scale, it's got to be easy. So we work to make deploying a LoRaWAN sensor as easy as deploying your Ring doorbell, your Blink camera system. You QR scan a sensor over here, one of your end devices, a number of different ones, whether it be a LoRaWAN bridge like the VolleyBoast, whether it be an energy monitor like Utility, whether it be a Vega sensor that you're measuring level on a tank. You can scan any of these devices, connect it to your LoRaWAN network server. And as Dan mentioned in his section, this is an example of a private network. I see some of the Q&A coming in is asking questions about public networks, and can't wait to get into that discussion during the Q&A. But this is an example of a private network that's running on the edge, where we're running the LoRaWAN network server on the conduit gateway, taking that data and forwarding it via MQTT to a Moxa device, the AIG 501. And the reason we like the Moxa platform is by leveraging the power of the Azure IoT core and other easy to deploy devices. We can actually deploy Ignition, our module, and all the software you need to enable this stack through a push to an edge device. So if you have to deploy 1,000 of these AIG 501s as you're looking to scale this across your enterprise, it becomes very, very easy to support and scale as you grow. And then here on the Moxa is where we're running Ignition, where we're running the SiteSync modules to support MQTT, and where we're running the SiteSync LoRaWAN module, which is 3 main components and features that we'll get into more in detail during the live demo section. But once you get your data to here, you get it connected, you get it decoded and normalized, then you use the power of MQTT and the openness of the Inductive Automation Ignition platform to get your data to a local HMI running Perspective or Vision, or taking that data up to the Azure cloud, consuming it in Power BI, taking it to other platforms from there. It really gives you the ability to get your data where you want it in a format that's usable for your enterprise. So this is an example of an edge architecture. When we go through our live demo, we'll be doing more of a cloud-based architecture. One of the things we like about this is if you want to switch this to a cloud architecture, you can take this gateway, set it to a packet forward mode, send it up to your LoRaWAN network server up in the cloud, and you can have your Ignition running on a virtual machine or running Ignition Cloud Edition with our module. And with a few clicks of a button, you've got a full cloud architecture versus an on-prem. So a lot of different options. The very, very cool thing about this architecture is it's modular. And as you invest in different pieces of it, you're not incurring technical debt because it can be changed out and modified as your deployments scale. So with that, we'll get into Ignition and the third-party module, SiteSync, running on Ignition. We've got 3 main components here where we, connect to an LNS via our LNS config. In this example, we're going to be having a MultiTech conduit gateway connected to a chart stack running in the cloud on the same Azure virtual machine as our Inductive Automation Ignition. We do an API connection to allow you to manage that LNS directly from Ignition on the third-party module. And then from there, you get into device management. And this is where we really see the power of that architecture. And normally when you're going to deploy a LoRaWAN stack, if any of you have worked with LoRaWAN, you know that there can be 5 to 10 different places you would have to troubleshoot a LoRaWAN device to make sure it's connected to your gateway and that the data flow is ending up where you want it. What we aim to do with this device management is give you one single pane of glass to manage your entire LoRaWAN stack. And with that, we'll go ahead and add a gateway or add a device and show you the power of QR scan. So I am running this on my mobile device using the Perspective app. So you can see device management running on my phone. I click add a new device. Launch the QR scanner. And I've got a Vega radar, an 80 gigahertz radar sitting here that I'm going to go scan the QR code. And it brings over my 16-digit WUI, my 32-character app key. It recognized the device type as a Vega Air, which helps associate it with the right decoder and UDT to use in Ignition. I hit done. I can go in, set my tag provider, tag path to get my contextual data. I can add in description. I can add in my device coordinates so I can have a map location of where I'm adding this device. I can also upload a picture of where I've installed the device so your field technicians can know what tank or what asset you've installed your LoRaWAN device on. So I hit save. I get a confirmation that the tag's been added successfully. And then I come back to Device Manager, hit a refresh. and now I see a Vega Air B26 has been added and activated. And I take my magnet, I wake up the device and get it to do a join and report in. So what it's doing is it's joining the LoRaWAN network server chirp stack, and now it is taking a measurement and reading level from the device. And so while we wait for it to read the level and update its tag, we'll go through some of the features of device managers. So what we've done here is you can easily see at a glance and see what device is operational, what devices haven't been activated. If you have a device that's got an error, can't see a gateway, can't connect to the LoRaWAN network server, it would throw a device error here. You've got data errors here. So if you have upstream data consumption through MQTT Sparkplug B, where your data connectivity has been lost upstream, you'll get data errors here as well. We'll go in, take an example, look at a sensor that's not been activated. One of the things we can do is a lot of sensors have the ability to report on change, or they'll report periodically every 4 hours, every 6 hours, every 1 hour. You can set that check-in status at the device level. And then through the power of Ignition, we can allow you to alarm and alert when you haven't seen a value in the set time frame you expected to see it. So we can see that this one's got a check-in status that's overdue. Over here, we can see where we've mapped the device. We can get a map view, see that it's in Baton Rouge, Louisiana, in the same office I'm located as well. Diagnostic data. This is where we can look at the LoRaWAN architecture and find exactly where in the stack we think we're having the issue. We think it's at the device level because we've never seen a packet come in from the device. And we know it's not at the network server level because we've got a live connection to our network server status. So with that, we'll go back over to devices and then go to the data tab. This is where your, tier 2 support level people, tier 1, your technicians in the field, they're going to be operating mostly from this screen using these devices. Your tier 2, your controls engineers, your automation engineers, and your tier 3 support level in your organization, your digital transformation teams, your central IT, they're going to be doing a lot of data consumption over here, making sure that you have the proper UDTs, decoders, doing diagnostics on the data flow, making sure that the devices that are coming in are writing tags successfully. When you don't get a tag right or have an error thrown here, we'll throw an error here. You'll have the ability to alarm and alert off of that, run exception reporting to make sure that your data flow and your network connectivity is reliable and what you're measuring, your users can count on. So with that, we'll hop over to Designer and pull up our drop config. So this is our perspective designer in Inductive Automation Ignition. We've got our tag browser down here. You've seen our Vega Air 66 that we added has come in. This is through the power of UDTs, we're able to create this tag structure. And so every Vega Air that you would add would come in with these parameters already specified. We've got our measured value came in. And then we've also added a folder called LoRaMetrics. And this is very useful for your technicians in the field, your network operators to know this is the signal strength the device is getting back to the gateway, your signal to noise ratio, your spreading factor, things that would help you troubleshoot why your LoRaWAN device might not be getting the connectivity you expect. So this is all contained in LoRaMetrics, and it's a standardized format we provide with the UDT. So also with Designer, we have the ability to create what's called a drop config. So after we scan the QR code and the data flows in, then we just drag the tag over to our dashboard. And with that, we have the value of our tank coming in. So very easy to go from QR scan, getting your sensor joined to your network to consuming data. And once you have the data in Ignition, as Travis hit in his section, it's really limitless where you can take the data from there. We believe Ignition allows you to connect data wherever you want to consume it in your architecture. So whether that's a legacy system that we get asked from heavy industrial users, hey, how do I get this into a historian? I already have deployed on site. How do I get into my DCS or PLC control network layer? And then we have other customers and end users who want to see us get it into statistical analysis software so that they can do machine learning, AI, and stuff from there. So with that, that kind of wraps up the live demo portion. And Oliver, I'll turn it back over to you.
Thank you, Michael. And it went by pretty quickly. Give me a second here. Let me move the screen here. All right. Thank you, Michael. That was very interesting and very exciting for me to see. I've seen this before, but I want to emphasize to the folks on the call how helpful it is to have these pieces already built out for you. For those of you who have worked with LoRaWAN before, and being sort of tied to the platform or the data as provided by the vendor versus having the tools that makes that data, as Travis also mentioned, democratized and usable in a usable format and available to any platform at the click of a button. You just watched Michael in the course of 5 minutes use his phone to scan the QR code and bring that module and the tags into Ignition live, without having to fiddle around with IP settings or configuration on a one-on-one basis. And he has the tools to monitor the device status of those sensors and add other vendor sensors at any time that he wants. And so that is the power of digitalization with these pieces together. So with that, I'll shut up and let's go to the Q&A section. For that, I don't think I need to share my screen, but we had some questions that have already come in. I'll go ahead and start going through those. And if you have other questions, please use this time to go ahead and enter them into the Zoom platform. So let's take a look at some of the questions. Yes, we will be sharing the presentation. Thank you for asking. Here is an interesting one. So I'm just going to read this one out loud, and someone join in. While crypto has its own stigma associated with it, coin called Helium attempted to create an international LoRaWAN network. In your opinion, should this network be taken seriously? Is the market demanding for an international paid-per-use LoRaWAN network? I feel that might be up Daniel's alley. What do you think, Daniel?
Yeah, I'll take a shot at that one. So I think we should take networks like Helium seriously. They've deployed the largest LoRaWAN network in the world, and it really is in the United States. Anywhere where there's any kind of population base, you can go on their website, see their coverage maps. They're pretty much real time. But it's true that it doesn't have very much traffic on it. It was really set up, with an incentive for crypto and not for making revenue by every connected object. And so I think it's upon us to, look for ways to use that. But it is a public network. And so I don't think you would want to put mission critical assets on there or assets that were part of a mission critical system. And yeah, there is a market out there for international pay-per-use LoRaWAN networks. And at the LoRa Alliance, we've done a lot of work to make sure that all the networks out there can interconnect with each other. But if you're looking for a network that is more CapEx driven, not paid per device, a million devices, you put another one on and you pay another contract. If you're looking to capitalize and you have a very focused area that you want to cover, then, maybe a private network is for you.
Thank you, Daniel. Excellent question, and thank you for asking that. Let's move on to another question. Is this software available for on-site servers? I think Michael and Travis, you both sort of spoke to it, but let's go ahead and answer that live, and for the benefit of our attendees.
Yeah, sure. I could start with the answer there. So absolutely, the software here can be for made for all on premise, and that's the example that you kind of showed at the beginning there. Having Ignition Edge on the Moxa device, that is at the edge. So data coming in, and then from there, you could push data up wherever you want. And of course, the central Ignition server could be on-premise, or all of it could be in the cloud. It could be a hybrid of the two. I mean, there's a kind of endless possibilities for how you want the architecture to work and what makes the most sense. For a lot of customers, they want to control everything and with their security models and their network infrastructures, and they want it all on-premise, and they want to follow Purdue model and all that. That's perfect. You could do that. However, if you if you want to experiment with some new devices and you want to get data straight to the cloud to do more with that information, there's nothing stopping you there either. So there's a lot of possibilities.
Yeah, and to kind of echo off that as well, the hybrid models is what we're seeing a lot of people look at right now, where they keep the data on-prem at the Purdue like level 3 and lower to consume the data, but then through the power of MQTT, Sparkplug B, and brokers, be able to make that data easily subscribable to the central IIoT team, the digital transformation team, so that they're getting their diagnostics, helping support these implementations across multiple sites, but still letting the local site keep data on-prem and meet that level of security that they need to. So very, very interesting things going on from an architecture standpoint.
And thank you, Travis. Thank you, Michael. And that just underscores the importance of choosing a platform that is flexible and scalable. So thank you for that question, and thank you for those answers, Travis and Michael. Here's another question. Can you run the product directly on the MultiTech Linux or container?
So we actually have run Ignition Edge and our software on the Conduit 300. You'll need a MultiTech product that has a little more processing power than the standard Conduit that we showed in the live demo. So they make a product called the 300, and it has enough processing power to be able to run some of the software. But it all depends on your architecture and how you design it up on where it's best to run each piece.
Thank you, Michael. Another question. How would you connect to OSI Soft Pi?
Well, there's different options for that. It depends on the kind of data flow you're looking for. If you want to get live data into Pi, Ignition exposes that through OPC UA, and Pi has support for collectors bringing that data in from that method. They say they have experimental connectors for Sparkplug, MQ Sparkplug, on bringing data in there as well. I have not validated that personally, but at least bringing live data, there's a couple different options for bringing live data in the system. And we also have people that from Ignition are leveraging their JDBC connector to push data into it, leverage things like OPC HDA. There's different formats that can happen, but the simplest is to go OPC UA or MQTT straight from those tags that Michael showed. All those tags will be accessible straight into a system like that.
Thank you, Travis. Hopefully that answers the question. Definitely beyond my understanding of the software architecture. So thank you for that. Here's maybe a follow-up question, maybe related. Elaborate on the integration with DCS, Historian, or Data Lake using Ignition. Or can we elaborate on that?
Yeah, it goes right into what Travis just answered. You know, once you get into that tag browser, then you have the opportunity with OPC UA, OPC DA, other options for getting data from there. If you have the ability to do Sparkplug, MQTT, Sparkplug B, or MQTT, the sky's the limit for you on where you can take the data. So whether you want to take it up to the data lake or whether you want to do more of a DCS integration. If you're doing a DCS integration, you're going to be doing OPC or God forbid, maybe some Modbus from time to time.
Yeah, I'll elaborate a little bit further in that there's, with Ignition, there's a lot of options for connectivity. And, once you have that data, as we said, OPC and MQTT are two very easy ways. They're meant to deal with data like that and to push it, out to where it needs to go. However, data can go into SQL databases. Data can go into IoT hubs or event hubs in Azure, can go into AWS, into various services that are there, direct injection of those services. It can go in, we can expose it through a REST API. there's a variety of different mechanisms. And as we go forward with Ignition, we're continuing to build more connectors to different services and other open standards. A lot of folks want Kafka built into Ignition. We're working on getting that support in there, so that it gives you the sky's limit option, right? That the data can get pushed to wherever you want it to go. So that's the true nature of democratizing data. We can't dictate for everybody what the one thing you have to do. It's just, no, we should support them all so that you can choose the one that's right for you.
Thank you, Travis. Excellent. We're getting a lot of questions, so there's a lot of interest in this topic. So thank you guys for making yourselves available for this. Here's one: is there an electrical energy meter device which has a direct LoRaWAN connection?
Yeah, the one we showed in the architecture, that utility device, that is the device that can do that. And it monitors energy usage, amperage, and it also is a unique LoRaWAN device where it can power itself off the energy source that it's monitoring. So you don't have to worry about changing batteries, battery life. Most LoRaWAN devices are getting you battery life in 5 to 10 years anyways, but this one truly can power off of what it's monitoring, and is one of those, you know, home run applications that we see a lot of end users going after. That is maybe that first LoRaWAN application into their site that justifies them building out a network, building out this architecture to then add others. Energy monitoring and usage is a big one.
Thank you, Michael. All right, here's another question. How do LoRaWAN sensors securely communicate through a LoRaWAN network to my application?
Yeah, I'll take a first stab at that one. So LoRa uses 2 layers of ciphering and authentication. So the network layer, so all of the traffic from the sensor to the gateway and the network server is encrypted using 128-bit TLS, which, you know, bear in mind the frequency of data, the volume of data coming through, you know, that's maybe a lifetime to get through, you know, all the ciphering sequences in TLS 128. And then at the application layer, so the raw payload going into the application server that then slices and dices the data and sends it off, in this case, to Ignition. That's also encrypted as well. And they can be synchronous keys, they can be asynchronous keys, they can be rekeyed in their lifespan. So it's pretty damn secure.
Thank you, Daniel. All right, here's another question. How are products marketed for LoRaWAN in different regions? Are there products that can be deployed globally?
Yeah, I'll take that one quickly as well. So LTE, right? You know, if you remember back, GSM, you know, it had kind of a couple of different frequency bands around the world, and then 3G, 4G, and we find ourselves with 100 different frequencies, all differing, you know, in different regional markets based on spectrum availability. Well, I'd love to say that sub-gigahertz LoRa works in the same frequency everywhere. It doesn't, but it's not nearly as complicated. There's about 7 or 8 different channel plans, they're called, and they typically work on 2, maybe 3 different frequency bands. So it's quite manageable, and there's also some adoption of 2.4 gig for things like maritime shipping, where, you know, assets on ships are literally going around the world. But typically, this hasn't been a big issue. Most of these assets stay in the regions, like the whole of Europe, the whole of North America. So by comparison to LTE, very manageable.
Thank you, Daniel. All right, here's another question. They keep coming in, so this is a very engaged audience. Do we need this software for every production site using LoRaWAN when using an Ignition enterprise architecture?
Who wants to take that, Michael? You want me to take a stab at it first there? I think it depends on the use case. I mean, typically, The reason that we put the Ignition Edge there with the SiteSync module, I know there's another question that was is that software, it's a module added to Ignition. It is a module that gets added to Ignition like other modules that is sitting there on that Ignition Edge. And the reason for that is it gets the data directly and it's at the edge, gets it at the edge, so that if there was any connectivity loss or whatever through the enterprise, that we would store and forward and have that information available and do what we need to do with it that way. So it comes down to the kind of classic classic questions architecture where I need to put things. You know, if you have networks that are really solid, you may not need to have it at the edge everywhere. You can have just a central server that collects data from these different devices. So, and as Michael even showed, a more extreme case is putting that in, running that module in the cloud, right, where you have that data being sent up there. So again, it just depends on use case. I think that anything else to add there, Michael?
Yeah, I think the biggest thing we tell people is wherever you're running in your Ignition gateway is typically where we install our module. So if you're running your gateway centrally, then we're pairing wherever the Ignition gateway is.
Thank you. I think that answers the question, but if there are follow-up questions, we can certainly take some of that offline for your specific scenario, and we actually will have a poll question after this to capture that. So we'll definitely be in touch with you guys after the webinar. Travis, you had mentioned store and forward. It seems related to this question. Does the device buffer if the receiving host is disconnected?
So that's the question between, I think, Michael, that's the question between the module and the actual MultiTech gateway.
Yeah, so we are actually working with the MQTT connection on the MultiTech gateways to make that a Sparkplug-B compatible MQTT connection, so that you'll have that store and forward capability. So the short answer is not today, but it is on our product roadmap, and we are hoping to release it to the market in the near future.
Thank you very much. Here's a question. Support for LoRaWAN-based firmware updates. Has the LoRa Alliance released that yet? How does the product support this?
Yeah, I'll take that one as well. So, LoRa Alliance has released that spec. It's a full technical specification. It's been around since about 2018 and has grown to encompass some other technical specifications and recommendations. It's referred to as firmware update over the air, so FUOTA. So it's fully standardized in a way in which the application layer can be open, to one operating system versus another. But there are some considerations to take into account, right? If you use firmware over the air update on a battery operated device, you have diminished the life of the battery. I'm not saying by 10 or 15%, maybe just 1% or so, right? But this isn't something like a smartphone where every month I do an update. Updates come at a cost, and that's battery life. So it's nice to be able to deploy assets and know that you could fix things and patch security issues. But this isn't something you do willy-nilly. You do it, with a very clear reason and the trade-off that you're making when you do that.
Thank you, Daniel. All right, we have time for a few more questions. We're coming up to the top of the hour, but guys, keep them coming in. Thank you very much for this level of engagement. Here is a very high-level question. What is the best way to get started with LoRa at my site?
I'd highly recommend finding that one use case, that one application that is going to give you the immediate ROI for justifying putting in the architecture, building out a gateway architecture, and just know that the best way to do it is to just get started. Don't worry about the different architectures, how to optimize it. If you choose a modular platform like we've shown today, you're not incurring technical debt. You have the ability to change things as you learn what best fits your structure and how your organization works. But we see, several applications that deliver that immediate ROI. We talked about utility and the energy monitoring. That is definitely one of them. asset reliability. So you take that utility, you pair it with a vibration sensor, you pair it with a temperature sensor like Radio Bridge makes, and now for $1,000 to $1,500, you're monitoring 3 different variables on an asset, and you can get a baseline of that asset's health and alarm and alert when it's outside that baseline. You can do machine learning AI directly in Ignition on those tags and be able to predict when an asset's going to fail. We see asset tracking in general manufacturing. I saw a lot of general manufacturing people on this call. That's one of the biggest ones we get asked for is, where is my stuff? And we see LoRaWAN kind of as, an upgrade over traditional tracking applications like RFID and barcodes, because it can actually report where it's at proactively. So I think asset tracking is another hero application for us. And then valve position. We have a lot of industries that are doing manual valves, and Aloxi makes a great manual valve position sensor. It's probably one of the most popular ones in the industries we serve, and has seen those 1,000+ end user deployments. So those are 3 or 4 that can help you get started and justify getting an architecture in place and go from there.
Thank you, Michael.
Yeah, I just re-emphasize that, just have clear goals, have a reason to do this. You're trying to achieve something, put those goals down, but don't get stuck in paralysis by analysis. Get moving and realize those goals.
Well, I'll just add that there's a ton of value in just being able to see your data, right? Get the data to somebody on their phone. I mean, I can't tell you how many times that pays dividends just by itself, because we're getting it to the right people. They're able to make those decisions. So Michael talked about that manual valve position. That's huge, because what would they do before that? They have to go out to each of the valves to check the state of that, to see what's happening. Now, by putting the sensor, somebody can get on their phone no matter where they are and can troubleshoot, understand what's happening in the system if there are other issues that are going on, right? So it is critical to get data to somebody. Yes, we can go a lot further and do AI and all that stuff, but to me, right now, most people just don't even have the data in their hands. Let's first start there.
Yeah. I love that we all have something we want to say. I actually wanted to add one kind of thing, just in my limited understanding of the sensor world. Moxa would do communication infrastructure, but to Travis's point, if you were trying to instrument something the traditional way, connecting something via PLC and an I/O module that's wired up and over Ethernet and over Modbus, that immediately eliminates the possibility of hitting these remote sites, large geographical areas. So one of the most exciting developments I see with LoRa is the fact that you can drop these battery-powered sensors. You don't need all of that heavy infrastructure to get data, and that's why this is such an exciting sort of technology for these kinds of use cases. All right, and one last question, and then for the ones that we haven't answered, we'll try to answer offline. But what kind of applications is LoRaWAN not ideal for?
Video. The amount of times I've been asked, this is great range, I love the cost, can I do a video camera? No, you can't. And then the answer is, well, maybe it doesn't have to be high definition, could be low definition. No, this is still not for you. Maybe it's just an image now and again. Well, doable, but this is not LoRaWAN. So it's not video.
All right. Well, I think that concludes all the information we have time for. I'm sorry we weren't able to get to everyone's questions. There are some really good ones and some really deep ones that I might have to reach out to individually and take offline. But before we go, we have one last poll question. We appreciate everyone's participation in this. If you want to continue this conversation offline with any of the 4 of us here, you go ahead and answer that poll. And then I think there is also a survey that we send by email, or maybe it live pops up afterward, just so we can get feedback on how effective and how informative you found this content. So I'll give you guys some time to take to answer that poll. And I want to extend my great thanks again to all the attendees that have taken time out of their day, to Michael, Daniel, Travis, for your expertise in providing this introduction to LoRaWAN digitalization with Ignition. And thank you very much for your time, everyone, and have a good rest of your day.